Good afternoon. I'm Dr. Smita, Associate Professor in Tokaj Institute of Science and Technology. Here I'm going to introduce the structural analysis software Staad. This introduction is basically for those engineering students who missed their lab classes on Staad due to Corona. We'll be dealing with three problems. First, a one-dimensional analysis, then a two-dimensional analysis, and then a three-dimensional analysis. So first, we'll move on to the first one-dimensional analysis. We'll analyze and design a cantilever beam. So first, we'll take the Staad, which is installed in the system, then File, New. This is a plane problem, so we'll take plane, and the location we'll take as, you can take any location, but here we'll take desktop and stand. Okay, we'll take it as structure 1 itself. We'll change the units as meter, kilonewton. Moving on to next, add beam, finish. So this is what you get here. So we'll analyze 3 meter length cantilever beam. So x is equal to 3 meter, y is 0 and z 0. X is equal to 3 meter, x is equal to 0, y equal to then y equal to 0, z equal to 0. That is the first point. Second point is x is equal to 3 and y equal to 0, z is equal to. So you get two nodes. These are called nodes. Then the next is we add beams, that is we join these two nodes, that is using. So this is the cantilever, this is the central portion of the cantilever beam. Now the next is you have to, now this is in the geometry. Now we have to move on to the section general. So in this one, first is the property. So we are in the property. So we have to define the sections of the cantilever. So first let us define a rectangular section. Here YD is the depth. Depth, let us assume it as 0.6 meters. It is 0.6 meters, and let the width be equal to 0.3 meters. The material is defined as concrete. So we are adding the material. Once you have added the material, you have to assign to the list. So use cursor to assign, taking assign. So and you click on the beam. So the beam material has been assigned. Now this is the property has been assigned. Now moving on to the specification. In this case there is no particular specification. The next is support. Moving on to the support. First you have to create a support. Create. So at the, this is a cantilever beam, so one end it is fixed. So you add the fixed support, then you have to use cursor to assign. So assign, and you click on the one end of the, that is you select the support to and click on to the one end of the beam. So the support has been assigned, and then next is, so that support has been assigned, you close that one. The next is load definition. So in this case, first load case details. So you click the load case details and add. So in this case, first we'll analyze for a concentrator load. So first let it be live load. The title of the load be live load. Let that be live. Add, and we'll add only one load case here. So close. So in the live, so you take the live and add what type of load it is. So let it be a nodal load, a concentrated load acting downwards. So in this case, F is the forces and M is the moments. So let it be Fy. Here Y is the vertical direction. So let it be Fy. Let load of Fy is equal to minus 50 kilonewton acted at minor node. So Fy is equal to minus 50 means it is acting downwards. So add, so you have added the load, you have added so many loads, so we will delete. You need only one load, that is Fy minus 50 kilonewton. Now select that Fy minus 50 kilonewton, use cursor to assign, and assign, you go to the next, that is the free end of the cantilever beam, you have assigned the load as minus 50. So that means we have assigned the load as minus 50. You can see the load acting downwards. Now the next is the material, which we have already defined concrete. Maybe we can change the material, as you can change the compressive strength. For the time being, it will be default value. Okay, so the material is also given. The next, that is all the values in general are given. The next is analysis bar print. So you take the analysis bar print, no print or print all, add, so close, and you have get the perform analysis print all. So with this, the next is, so you analyze, that means now move on to the command analyze, run analysis, save, and your analysis has been done. So maybe you can stay in modeling mode. So done. Now so it is modeling. Now the next is the we move on to the post processing mode. The only one load case is there, that is the live. Okay, so it gives the structure displacement, that is the nodal displacement is given, horizontal, vertical, and horizontal, vertical displacements are given, and from this you can get the displacements here, and the reactions at the node. You can calculate the reaction. You see the reaction at the node is minus 50 because there is no other force acting. Then that is the node. Then you can calculate the beam forces are there. You can calculate the stresses. You can that is the values are given. From the force you can calculate. Then graphs, there is a graph, that is bending moment graphs are given. So this is in kip Newton, and this is Fy is in kilonewton, Fx is in kilonewton. So you can calculate the moment also, you can calculate. So that is the analysis is over.